Hello friends, today we will discuss class 10 chapter number 1 chemical reactions and equations. This chapter we will cover in two parts in which the first part is balancing a chemical equation. So the very first thing is why do we balance a chemical equation? So in class 9 we have read about law of conservation of mass. Law of conservation of mass, it says that mass can neither be created nor be destroyed. It only changes from one form to another. It means whatever is the mass of reactant is always going to be equal to the mass of the product. So this is called law of conservation of mass, and we will prove this by balancing a chemical equation. So basically, when we are balancing a chemical equation, it means we are balancing number of atoms. So the number of atoms on both sides, reactant as well as product, they should be equal. So first thing that if I talk about the very basic one, so the part or the substances which are written on the left side of the arrow are called reactant, and of this arrow are called product. So while writing reactant and product, we also mention their state. So if I write S, it means solid, L means liquid, and small g means gases. So let us begin with the very simple ones. Also, one thing, while balancing a chemical equation, although there are many methods like hit and trial, then we have tabular form, then algebraic form. But what I have observed is while balancing, if we follow this priority order, first balance metal, then second balance non-metal, then at third place balance oxygen atom, then at fourth and last balance hydrogen. So if we follow this sequence, balancing becomes very easier. Metals like we have sodium, potassium, calcium, magnesium, aluminium, zinc, etc. Non-metals like we have carbon, sulfur, oxygen is already included in this one. Then we have chlorine, bromine, then iodine, and many more. Then third, of course, we have oxygen. O, oxygen means oxygen atom. O, then at last balance hydrogen. One more thing, while balancing any equation, we can, if I give you a simple example, like any general equation, A plus B, it gives C plus D. Suppose while balancing any equation, I have to write XA. So whatever we are writing, we can write before the reactant or the product. Means we can play with this number. If I write A and I have to write X atoms of A, writing in this way is incorrect. This is not allowed, or it is incorrect. So if I have to write XA, it should be written like this only, because this is called stoichiometric coefficient or moles basically. So we can play with this number, means which is written in front of the atom, not the coefficient which is written as subscript. So I will give several examples. So let us discuss it one by one. So the very first example, simple example, hydrogen combines with oxygen to give H2O, water. So what is the priority order? First metal, then non-metal, then oxygen, then hydrogen. There is no metal, non-metal. So directly we will balance oxygen first. So on the product side, we have one oxygen. On the reactant side, we have two oxygen. So I will write 2 here. Now again, same thing. While balancing oxygen, I have written 2 in front of H2O. What if I write H2O2 here? It will be incorrect. Why? Because the moment I write H2O to balance oxygen, if I write it as H2O2, this is incorrect. Why? Because entire formula is going to be changed. This is water, whereas H2O2 is hydrogen peroxide. Hydrogen peroxide. That means, instead of balancing the equation, we are entirely changing the compound. That is why we cannot play with this number. It is always has to be this number which is written in front of this. So now let us balance this equation again. So I have written H2 plus O2. So this is 2H2O. So to balance oxygen, I have written 2 here. 2H2O. Now, oxygen balance. What about hydrogen? Hydrogen is 2 2s are 4 because H2 is already there. So multiplied by 2, 2 2s are 4. On the reactant side, we have only 2H2, so I will write 2 here. Now this equation is balanced. Another example, if I take N2 plus H2, it reacts to give ammonia, NH3. So again, what is the priority order? Metal, non-metal, oxygen, hydrogen. There is no metal, only one non-metal, which is nitrogen. So on the product side, we have one nitrogen. On the reactant side, we have two nitrogen. So what I can write? 2 here. Again, if I write N2, it will be incorrect. So always change the number which is written in front of it. So now two nitrogen atoms are on the both sides. What about hydrogen? Here we have 2 3s are 6H, whereas on the right side we have only H2. So I can write 3 here. Now this equation is balanced. So if I write the balanced equation, it will be N2 plus 3H2 gives out 2NH3, balanced. If I take few more example like CH4 methane, it reacts with oxygen to give CO2 and H2. So again, check the equation. There is no metal, so we have only one non-metal, which is carbon. Carbon on the reactant side is again 1. It is also 1 on the product side, CO2. So no need to balance carbon. That is already balanced. Then think about next atom is oxygen. So on this side we have O2. On this side we have O2 and O1, 3. So on the left side we have 2 oxygen, on the right side we have 3 oxygen. So whenever there is such case, means while balancing you come across even and odd number. So leave that atom. Leave it. Balance the next atom. So next atom is hydrogen. So on the reactant side, H4, hydrogen atom are 4. On the right side we have H2. So what I can write? 2 2s are 4. Hydrogen balanced. Now again calculate oxygen. So on the reactant product side we have O2 and 2O. Total oxygen 4. On this side we have only reactant side only 2. Now I will write 2. So this is the balanced equation. CH4 plus 2O2 CO2 plus 2H2O. So what you have to remember is whenever there is a case of even odd, leave that atom and balance the next one. One more example. If I write Fe plus H2O, it gives Fe3O4 plus H2. One more thing that you have to remember, you can change the number which is written in front of this at this position, not the number which is written in subscript. Always remember that. You cannot change that number because it will change the entire molecular formula. Wait. So what I can write is Fe3O4 H2. Now let us balance this equation. So in this case, we have one non-metal. Sorry, we have one metal which is iron. So this side we have 3 iron. This side only 1. So I will write 3 here. So 3 Fe iron balanced. Think about the next atom. Next is non-metal which is oxygen. So on the product side we have 4O. O4. This side we have only one oxygen, H2O, only one. So I will write 4 here. Now total hydrogen. On the left side, reactant side, we have 4 2s are 8. On this side, we have only 2. So I will write 4. Hydrogen is 4 2s are 8. Hydrogen is also balanced. This is the balanced equation for this reaction. Combustion, iron plus water. Next reaction. If I take CuO, cupric oxide, plus NH3, it gives Cu plus N2 plus H2. So again follow the same order, metal, non-metal, then oxygen, hydrogen. So first we have metal, copper. This side we have one copper, this side we have one copper, balanced. Next atom is oxygen, non-metal. Sorry, next is non-metal. So we have next non-metal is nitrogen. This side one nitrogen, this side two nitrogen. So what I can write? 2 here in order to balance nitrogen. Next balance, let me remove this one. So next is to balance oxygen. So this side we have H2O, right side, product side we have one oxygen, reactant side also we have one nitrogen. So nitrogen is again balanced. Next is hydrogen. So on this reactant side we have 2 NH3. So 3 NH3, 3 2s are 6. H6 on the reactant side, this side we have only 3. So I will write, sorry, this side we have only 2. So I will write 3 2s are 6 hydrogen on the product side. But the moment I write 3H2O here, so oxygen atoms also become 3. So again to balance oxygen, because oxygen is now 3. So to balance oxygen, I will write 3 here because copper oxide is there, cupric oxide. Again, so the moment I have written 3 here, now copper is also 3. So to balance copper, I have to write 3 here also. This is the balanced equation. Okay, so now let us discuss next example. If I write one more example, MnO2 plus HCl, it gives MnCl2 plus H2O plus Cl2. Again, balance first metal. So on the left side we have one manganese, on the right side also we have one manganese metal. So metal balance. Next is non-metal. Non-metal is chlorine. So this side 1 Cl, this side 2 Cl plus 2 Cl, 4 Cl. So to balance this one I will write 4 HCl. So now we have 4 chlorine atom on both sides. Next is to balance oxygen. So to balance oxygen we have MnO2, this side 2 oxygen atom, whereas only one on the product side. So I will write 2 here to balance oxygen. Last atom is hydrogen. So this side we have 4H, this side again 2 2s are 4H. So hydrogen is also balanced. This is the balanced equation for this reaction. Okay, next. What happened? AlC3 Al4 C3 plus H2O, it gives CH4 plus AlOH, aluminium hydroxide. This is the reaction. This is AlC3. So first balance metal. So this side, reactant side, we have 4 aluminium. On the right side we have only 1 aluminium. So what I can write is 4 here. Next, balance non-metal. So non-metal in this case, what we have is carbon. So this side we have C3, 3 carbon atom. On the right side we have CH4, only 1 carbon. So I will write 3 here to balance carbon. Next is oxygen. So on the reactant side we have only H2O, only 1 oxygen. Now listen, when it is written AlOH whole thrice, so it means O thrice, H also thrice. Now again multiply this 3 by the number which is written in front. So total oxygen O 3, 4 ja 12. So total oxygen atoms are 4. HOH whole thrice written. So again H 3 4 ja 12. So H is also 12. So anything which is written in whole twice, so it represents for everything. So carbon balance, aluminium balance. Next is balance oxygen. So this side we have H2O, only one oxygen. This side we have calculated 12 12 each. So to balance oxygen I will write 12 in front of oxygen. So oxygen balance. Next is hydrogen. So 12 twos are 24 hydrogen on this side. Again H12. So O3 O3 and this 3 fours are 12H in this case, and C4 H4 3s are 12H this side, total 24H. So again 12 to 12 H2, so 12 2s are 24H on this side also. So that means both hydrogen and oxygen are balanced. So in this way we have to balance any equation. Next, let us take one or two more examples to balance this equation. Like I have NH3 plus O2, it gives NO plus H2O. So first in this case we have nitrogen, so balance nitrogen. On the left side we have 1N, NH3. Again on the product side we have 1N, so nitrogen balanced. Next atom is oxygen. So this side we have O2, this side O1, O2. Both oxygen balanced. This side we have NH3, this side we have H2. So one side hydrogen 3, one side hydrogen 2. So what I can write is, write 4 3s are 12. So 4 3s are 12, or this becomes 12, means 4 3s are 12, hydrogen becomes 12. So again, in order to make hydrogen balance, I have to write 6 here, because 6 2s are 12. The moment I write 6, that means nitrogen atom also become 4. So in order to balance nitrogen, I have to write 4 here. Now calculate oxygen. So oxygen we have 4 nitrogen oxygen here and 6 oxygen here. So 6 4s are 10. So to balance oxygen, I have to write 5 here. So now this equation is balanced. So NH3, this one. In this way, we have to balance any chemical equation by following this trend. First metal, then non-metal, then oxygen, after that at last hydrogen. Most important thing is to note that while balancing I can write X atoms of A, Y atoms of A, or whatever. It is incorrect. AX is incorrect, means you cannot write it in this way, and this representation is correct, which is written in front of that. So this was all about hit and trial method. In this method you have to change the number again and again. So now let us quickly discuss one more method which is important, although not required for school exams, but you should know. And this one is coefficient method or algebraic method, whatever you call. So I will take 2 or 3 simple examples. Coefficient method or algebraic method. So in this case, let us discuss. I will take example directly. So if I write NH3 plus O2, it gives NO plus H2O. So in this method, simply first we have to choose the factors, whatever we have to balance. So I will write A, B, C, D. So whatever reactant or product you have, suppose in this case we have 2 reactant, 2 products, so I have written A, B, C, D. Suppose in any reaction we have 3 products, so I will write A, B, and in 3 products C, D, E, simply, no problem. So next, whatever atoms we have, how many different type of elements are there? So we have nitrogen, then we have hydrogen, then we have oxygen. 3 different type of elements we have in this equation. So make equations according to these atoms. This is most important step. So with respect to nitrogen, what equations I can write? Nitrogen is present here in NH3, and that to only one atom. So only single atom, and which coefficient is written in front of it? A. So what I will write? Nitrogen, only one atom. So 1 multiplied by which number? A. So I can directly write A. There is no nitrogen here, but nitrogen is present on the product side. So whenever you are writing reactant to product, put this equal to sign. So I've written A is equals to. Now on the product side, in NO again we have one nitrogen along with the coefficient C. So I have written A is equals to C. So this is the equation with respect to nitrogen atom. What about hydrogen? So again in NH3 we have 3 hydrogen atom. So 3 is the number multiplied by the coefficient. Which coefficient? 3A. There is no hydrogen atom in this case, so I have not taken B coefficient into it. Again, no coefficient of H from this side, but in H2O we have 2 hydrogens along with the coefficient D. So I have written 2D. Let me remove these. So take note down those elements and then make an equation with respect to them. Now what about oxygen? So in this case in reactant we have O2 along with the 2 oxygen atoms along with coefficient B. So 2B is equals to, but oxygen is present in both C and D. So in C we have NO, only one oxygen, so 1 multiplied by C is C plus H2O, again one oxygen, so C plus 1 oxygen in H2O, 1 into D, so D. Is it clear? This is the most important step. After this, assume any coefficient A out of A, B, C, D, assume any one to be equals to 1. But that coefficient has to be taken as 1 which is most repeated one, which occurs in maximum in probably in all the equations. So either I can assume A to be 1 or I can assume C to be 1, any one of them, because A is here and C is here and C is here, so I can take any one of them. So let us assume let me change the color. So if I assume, let C is equals to 1. So the moment I assume C equals to 1, so from this equation, first equation, if C is equals to 1, I have assumed C is equals to 1. So since A and C are equal, so A will also be equals to 1 because A and C are equal, and I have assumed C to be 1. Is it clear? So again, if A is 1, so put this value in equation of hydrogen. So if A is 1, this will be 3 into 1 is equals to 2D. That means 3 is equals to 2D. So D will be 3 by 2. Okay. So now I have the values of A, C and D. So put these three values in the third equation, which is of oxygen. So in order to calculate the value of 2B, I know the value of C, which is equals to 1. I have assumed, plus D will be 3 by 2. So what I can write? 2B is equals to 1 plus 3 by 2 is 5 by 2. So B will be 5 by 4. These are the values which I have. A is equals to this. These four values are there. Now remove these number in the parent equation. So A removed, B removed, C removed and D removed. And put these values whatever we have. So A, this A is equals to 1, C is equals to 1. So in the place of A, I have written 1. In the place of C, I have written 1. B is 5 by 4. So this was B, 5 by 4, and D was 3 by 2. So this is the balanced equation. But again, we cannot write any number in fractions. So in order to remove the fraction, so multiply this equation by the highest denominator value. So in denominator we have 2, here we have 4. So multiply the entire equation by highest denominator value, which is 4. So when we multiply this entire equation by 4, what is the final equation? So 4 multiplied by this 1. So this will be 4NH3 plus 4 multiplied by 5 by 4O2. So this will be 5O2. Then 4 multiplied by 1NO. So this will be 4NO plus 4 multiplied by 3 by 2. So this will be 6. 3 by 2 into 4, this will be 6 H2O. This is the balanced equation. This is the balanced equation. So in this way, we have to balance any equation. So assume whatever equation we have, write it the equation, then assume the coefficients a, b, c, d, e, f, whatever it is. Let any coefficient to be 1 and then equate the values. Let us solve one more question using the same method. So second equation, if I write with using this equation is, let us discuss NH3 plus Cl2. This gives N2 plus NH4 Cl. So again assume coefficients. So again we have 4 coefficients A, B, C, D. So what are the different elements that we have? We have nitrogen, we have chlorine, we have a third one is hydrogen. Make equations with respect to them. So let us make equation with respect to them. First, nitrogen. So in this case NH3 we have only one N. So 1 into A is A. There is no nitrogen in Cl2. On the product side we have nitrogen in both N2 and NH4Cl. So this side N2, so 2 multiplied by C, this will be 2C, plus in NH4Cl we have only one nitrogen, so 2C plus D. This is the equation with respect to nitrogen atom. For hydrogen, in NH3 we have 3 hydrogen, so 3 into A, 3A. No hydrogen in Cl2, no chlorine in N2, and 1 chlorine in NH4Cl. So 1 multiplied by D. So what I can write is, wait, this is with respect to chlorine. So Cl with respect to this, so we have Cl2, so 2B is equals to this NH4Cl, so only 1D, so 2B is equals to D. With respect to hydrogen, this is NH3, 3 into A, 3A is equals to 4D. These are the equations that we have. Assume any equation to be 1. Now it is quite simple that we can I can see that D is here, D is here, D is here. So let us assume, let D is equals to 1, because D is the most repeated factor. So if I take D is equals to 1, look at this equation. So when D is equals to 1, 2B becomes equals to D, so this will be 1, so B will automatically come out to be 1 by, so when B is 1 by 2, so again when D is 1, from the equation of hydrogen I can write 3A is equals to 4, since D is 1, so A will be 4 by 3. So when A is 4 by 3, so put these values in this equation, in the equation of nitrogen. So from this equation what I can write, A is equals to, see, A is equals to 4 by 3. So I will write directly 4 by 3 is equals to 2C. 2C plus D is 1. So what I can write is 2C is equals to 1 minus 4 by 3. So when we solve this equation, what we have is C is equals to 2C is equals to 1 by 3, which is equals to C is equals to, it will come out to be 1 by 6. So write these values in front of this coefficient A, B, C, D. So write these 4 coefficients. A is what? A is 4 by 3. So at the place of A, write 4 by 3. At the place of B, we have B is 1 by 2. So B will be 1 by 2. C is 1 by 6. So this is 1 by 6. D is 1. We have assumed it to be 1. So this will be 1. Again, so to remove these fractions, multiply it by the highest value of the denominator. So we have 6 as the highest value. So multiply this equation by 6. So when we multiply this by 6, we have the final equation, which will be 4 by 3 into 6 NH3. So this will be 8 NH3 plus 1 by 2 into 6. This will be 3 Cl2. This will give out 1 by 6 into 6 will be 1. So N2 plus D, at the place of D we have 1. So 1 into 6 will be 6 NH4Cl. This is the balanced equation that we have done. So in this way we can balance any equation. So I will give 2 or 3 equations for your practice. Balance these 3 equations using coefficient method. So first one is CuO plus NH3. It gives Cu plus N2 plus H2O. So in this case, you have to assume A, B, C, D, E. So assume any number to be 1, either A or B, whatever you want. Second question for practice is S plus HNO3. Sorry, S plus HNO3. It will give out H2SO4 plus NO2 plus H2O. Third and simple question. C4H10 plus O2. This gives out CO2 plus H2. So practice these 3. Thank you so much.